Hello everyone, welcome to this TechnologyCatalogue.com webinar. Today we'll focus on smart solutions to maximize plant availability. My name is Vincent van Beuzenkom. I'm managing partner at Deployment Matters and I'm responsible for the Technology Catalog development and operations. Today I'm joined on my side here in Delft in the Netherlands by Jeroen Pronk, who's the owner of Valvetight and will be presenting the double block and bleed saver technology today. Online, we also have Mark Parker from MOVUS, live from Brisbane, Australia, who will be presenting the technology from MOVUS today. And we're joined by Erik Rutgers. Erik is our expert on production excellence from our expert network linked to the Technology Catalog, and he will actually be hosting the Q&A sessions for today. Before I hand over to Mark, I just want to quickly navigate you to the technology in the Technology Catalog. So for that, I'll quickly share my screen with you. Failed on the attempt. There we go. So on the screen, you see the homepage of the Technology Catalog, where we can navigate through the different modules. And today we'll focus on two technologies in the module maintenance and integrity. And within maintenance and integrity, there are different subject matter areas. And just quickly scrolling through, we're actually in the category proactive monitoring. We'll find the technology from MOVUS. What you see here is a subset of the technologies in that module. By going to view all, we can dive in the full module and we find the FitMachine technology from MOVUS. We have a nice picture here of the technology. And this is the page with all the specifications. But I don't want to give away all the information. Actually, at this moment, this is where I want to hand over to Mark to present the FitMachine technology. So Mark, over to you.
Well, good morning and good evening, everyone. And I believe Vincent will run the video in a moment. Just want to say thank you, everyone, for joining the webinar. And we'll run a quick video to introduce our solution called FitMachine, which is a continuous condition monitoring platform.
Yeah, we'll start now.
FitMachine is a true end-to-end solution for monitoring industrial equipment 24/7, offering all the components to monitor your equipment in real time. The FitMachine is a compact wireless sensor which collects data on vibration, acoustics and temperature to predict machine failure. Comprised of a printed circuit board, battery, rugged casing and a magnet for installation, FitMachines utilize a microphone and accelerometer to continuously collect data. You can easily install the FitMachine using no tools or adhesives. Simply attach it to your equipment using the magnet. There is no need to shut down your equipment. Once installed, onboard the sensor with our mobile FitMachine app. Scan the QR code on your sensor. Then the app will take you through a few simple steps to onboard your FitMachine to the machine cloud. Our machine learning algorithm establishes your equipment's normal operating behavior, which is then processed and analyzed by the machine cloud using artificial intelligence. The machine cloud dashboard gives you full visibility into this behavior and the health of your equipment, displaying the condition and trend of your equipment degradation over time. When your equipment behaves abnormally, the machine cloud dashboard sends alarms via SMS and email so you can determine your course of action. You can either continue monitoring your equipment, wait until upcoming planned downtime, or take action immediately. So there you have it, the FitMachine, which is simple to install and use, costs less than one inspection visit per month, and provides 24/7 condition monitoring, minimising unplanned downtime and production interruptions. Start monitoring your equipment today. Request a demonstration of FitMachine.
Thank you. I'm good to continue now.
Yep.
Perfect. Thank you. So that was a quick introduction to FitMachine. And just for perspective, I'll just show you very quickly. So this is the FitMachine device sitting in my hand, and you can see there it's roughly 10 centimeters across and sits about 5 centimeters high. This is our FitMachine standard device, and the other device I have here, this is what we call FitMachine EX. So this is actually certified intrinsically safe, down to zone 0 in gaseous environments. And there's a technical specification sheet on the Deployment Matters website, the TechnologyCatalogue website as well. So, so Vincent, happy to go to the slides. Thank you. So FitMachine, as I said, is an industrial IoT solution. It's designed to monitor the condition of fixed rotating assets, so pumps, motors, gearboxes, compressors, etc. Across a very diverse range of industries, from oil and gas through to chemical manufacturing, fertilizer plants, all the way down to food and beverage manufacturing as well, commercial haystack, etc. So and this is an excellent topic for us in terms of maximising plant availability, because ultimately unplanned downtime is a significant issue for most industries. And the reason we looked at FitMachine is we really wanted to challenge some legacy attitudes to maintenance and reliability. And what we saw was the emergence of low-cost, robust sensors and Wi-Fi technology. And that allowed us really to say, well, if we look at the old model where there's either no continuous condition monitoring and we tend to run to fail, how do we start to change those attitudes and I guess deliver consumer-like simplicity of technology down into the plant floor? And one of the things we've seen is that unplanned downtime has a significant cost to industry, and in a lot of cases it has a direct impact on the competitiveness of companies if they can't keep their reliability or hit their OEE numbers if that's where they're focused. So, and across industry, the numbers vary. We know from the mining space, unplanned downtime can start costing millions of dollars per day. But ultimately what we're focused on is helping plants be more reliable, because the other consideration here is that we tend to focus on the dollar loss, but what we also need to consider is that unplanned downtime or breakdowns also impact worker safety. We know that urgent repairs end up costing more because you lose some of that purchasing power, but the workplace risk is one that a lot of our customers are focused on. They're very focused on getting workers out of harm's way. So what we can do with FitMachine is provide continuous condition monitoring, which means if they can see the condition of an asset, they can actually start to reduce inspections that add little value to the organisation, and really allow them to move to condition-based maintenance, whereas really if you can see a change in condition, you can actually then determine maintenance or plan maintenance based on that. So, and I should mention, when you saw the package, what we measure with FitMachine is temperature, vibration, and noise or acoustics. So those three parameters are captured by our sensor. We sample every 5 minutes, and we use AI, as you saw in the video, to essentially build a unique model of the condition of an asset and then look for changes in that condition, really the early warning system, so that we can actually help companies get to an asset before there's permanent damage or a failure. So, and I'll just, sorry, I was hitting the wrong button. What you see here is an example of our AI output and how maintenance teams can use it. So what you can see on my screen there is on the left-hand side is the green line is the AI reporting on the current condition. Now, clearly you can see there's a trend up there across that December period through into late December. And it was actually in late December this particular customer took this asset offline because they felt that the condition was heading towards either damage or a breakdown. And then you can see, fortunately, over the Christmas New Year's period, they were able to undertake a repair. And then come the New Year period, they were able to bring it back online, and the condition was returning back to normal as they resumed operations for the year. So this really is indicative of the type of value that we deliver, in that we have this trend line that allows maintenance and reliability teams to understand where do they need to focus their efforts. And as I say on the slide there, FitMachine is really not saying we replace maintenance teams, we help them work smarter. So we're augmenting their human expertise so that they can actually deliver higher value outcomes into organisations. And we've seen that with a number of our global customers where they've been able to actually take their current workforce and do higher value reliability work. So more reliability planning, better maintenance scheduling, and also making a positive contribution to things like OEE targets, which is very, very important in manufacturing as well. So I guess, Erik, that's essentially what I wanted to present inside 10 minutes. I'm happy now to open it up for questions, or if Erik, you had any questions for me. So.
Yeah. Okay. So
online, you can leave your questions by typing them in the chat functionality. So you can start right away if you have any questions.
Okay, I will watch if some questions come in. But to kick it off, Mark, an interesting story. Basically, the first question I have, is it also suitable for turbines? Because you mentioned pumps, compressors, etc. But can it be used on turbines as well?
Yes, it can. So essentially we look at a pretty diverse range of assets, and behind the scenes where we focus is on typically on continuous running assets, so running generally more than 8 hours a day. I know it depends on the size of the asset as well, Erik. That's a good question, because where we found the real value with FitMachine is on what we call balance of plant assets, or the B-class assets. So yes, we can monitor turbines, but quite often they have some fixed instrumentation. And there's no value in having two sets of instrumentation or monitoring on those larger assets. So typically it is the balance of plant where we deliver most values.
Yeah. Okay. Thanks for that. So the second question I have is, it looks quite handy. Yeah, it's magnetic, etc. And if you want to implement this system in your organization, what is required on own resources, basically from the company I work for? If I decide to buy or lease this device, what is typically the implementation time and maybe on cost or effort? Can you elaborate a little bit on that?
Yeah, I'll break that. That's an excellent question, Erik. You packed about 5 questions in there, so I'll try and unpack them one by one. So the first thing we do with customers is initially engage on what we call a proof of value phase. In essence, what we look to do there is deploy the sensors across a good set of assets, typically anywhere from 40 to 100 assets, and then work with the maintenance teams to help prove out the value. So find something they don't know about that they can then determine or contextualize into value for the organisation. So the sensor, it literally is a 5-minute process to get the sensor installed and onboarded. And we use the phrase installed in minutes, creating data in hours and delivering value within days to an organisation. So typically it's a 5-minute process to onboard and have the sensor wake up and go to work. And that's obviously conditional on access to the asset. So, we have a number of projects, for example, here in Queensland at an alumina plant, where some of the assets are already being monitored, but there's a group where they're waiting for a shutdown in order to get safe access to the equipment. So typically they're up and running very, very quickly. You don't need any special skills. You don't need tools. It literally, you hear the magnet slap there, so that literally slaps onto the asset and wakes up and starts capturing data, which allows our artificial intelligence engine to go to work on learning about normal.
Excellent, thanks. Okay, time-wise, I think Vincent, it's back to you after these questions.
Yeah, I think there's no questions from the people online. Maybe one question, Mark, from my side, is that you mentioned the link also to the AI platform, but I guess it starts with the fact that you collect the data from the sensor. Would it be a starting point already for asset owners? Can they use your instrument just also for data collection? So, for example, if they have a failure on an existing sensor, to quickly replace that with the FitMachine, irrespective if they make use of the AI component?
Look, I'll give you feedback from customers across Australia, the US, and even some of the European customers. It's the AI where they get most value. So because essentially a lot of customers don't want more raw data, they actually want insights that allow them to make better decisions faster. So yes, we do collect some raw data like utilization and temperature, but ultimately it's the value in the AI, which is how we communicate any changes in condition, which is where most value is created for the organisation. Now, having said that, we've also got an API component which allows data to flow down into historian products like OSI SoftPy or IBM's Maximo platform. And that's also very, very exciting because it actually then allows asset planners to overlay different sets of data to better understand, is the manufacturing process causing a change in condition, or can we optimize how we use this asset and protect its condition?
Yeah, okay, no thanks. I think there's one interesting question online. Let's tackle that one before we hand over to Jeroen.
Okay. They actually stuck 2 questions in there as well. You guys are pretty good at multi-question questions. So first of all, about the size, there is just one size to the sensor. We have packed a heck of a lot of technology in there, but we are, as technology improves, and this is the advantage of the subscription model, we will see the size of the sensor reduce over time. So, but it is already a fairly small footprint, as I said, 10 centimeters diameter. And to the second question, yes, that would be a good application, a lube oil cooling fan for a gas turbine. Actually, in a lot of, we get deployed onto a lot of assets where they've tried fixed instrumentation in the past, and typically it's broken or it's become redundant. And this is the value of FitMachine, is so quick and wireless to deploy. And then we essentially get up and running and learning about that condition of the fan. So that's a good question.
Okay, thanks. So I think I would like to leave it there for the FitMachine. Thanks very much, Mark, for that. For the next technology for today, we stay within the maintenance and integrity module, but actually slightly different sub-module that we focus on for the next technology can be found, for example, in mechanical and welding section. It's the double block and bleed saver technology from Valvetight. So again, picture is shown on the screen here. But at this moment, I would also like to hand over to Jeroen Pronk from Valvetight, who will be presenting their technology for you today. So Jeroen, over to you.
All right. Good morning, everybody, or good evening, wherever you are. Yeah, I'd like to introduce to you our technology, the double block and bleed saver, which is used. Next slide. Which can be used in an array of applications. It is used both in gaseous media, but also liquid media or regular liquids like crude oil and naphtha. As an example, we have a compression station where one compressor needs to go out of operation and the remaining 3 compressors stay into operation. But instead of a compressor, you can replace it for a pig trap, metering speed, or any kind of piece of equipment that needs to be safely isolated using valves or turning a spectacle blind. This button, right. So if you have a double block and bleed situation and you have leakage in your bleed, which makes the work on the safe work area not safe anymore. What are then your options? You can, of course, find an isolation point more upstream. That means in our example, closing the whole header, which means the other 3 compressors are also out of operation. Or you can postpone the planned maintenance work, which sometimes is possible, but sometimes is not desired at all. If possible, you can inject grease or sealant into the valves, which sometimes works only temporary and sometimes also does not work at all. The disadvantage of using grease or sealant is that the grease or sealant will disappear over time while you're still might be working on the safe work area. So that means a sudden gas release is possible, and your operator usually checks once every shift and not every second. Or, and that's number 4, with the small leakages, you will accept the leak rate and find additional measures to mitigate the risk. And that usually means, on the right-hand side of the bow tie, you rely on PPE and that kind of things. And you want to mitigate the cause at the source of the problem. Which is what we've done by, instead of having a classical double block and bleed situation, we connect to the bleed our DBB saver tool, and we convert the double block and bleed into a double block and vacuum. And the big advantage is over the second block valve, the flow of the direction of flow is reversed and is led away from the safe work area. That means all the gas passing from the pressurized area through the first block valve can never pass the second block valve towards safe work area. And we monitor online as well. And the added value of this solution is that we build in more layers of protection to enhance the safety on the safe work area. The most important one is, of course, that we mitigate 100% the leakage, so no gas or liquid can enter the safe work area. We prove online and continuously. So instead of an operator checking every shift or maybe twice every shift, we do it every second. In case the leak rate or the passing rate exceeds the capacity of our tool, there will be an alarm, and this alarm is local. And this alarm can be relayed wirelessly to the central control room and also to the safe work area if that's not in the vicinity of the double block and bleed configuration. And we exclude to a large proportion the input of the human factor. So this machine is completely automated instead of the human observing subjectively the passing rates of double block and bleed configurations. So the first added value is the safety is maximized. The second one is that we lose a lot of emissions. So we don't have to depressurize bordering installation parts or pipelines. And then the third one, of course, is that those stay in operation. So you have maximum plant availability while doing your maintenance as planned and intended. So you become also very reliable in planning your maintenance instead of hoping that your double block and bleed configuration is holding while your maintenance crew is waiting in the hotel if it's not holding. And number 5 is, there is less necessity for direct and emergency valve repairs, which is often not feasible at all, because to repair a valve, you need double block and bleed further down the line. It avoids the necessity for turnarounds to do a lot of smaller leakages repairs. It works for classical double block and bleed, so 2 main pipeline valves and a small bleed valve or a drain valve. But it also works in single valve applications, for example, a ball valve or a plug valve or a double acting gate valve are typical examples that it works on a single valve. And for a ball valve, in this example, we see here the analogy. So the upstream and the downstream seat are touching ball. If they're active or not, doesn't matter. If you can connect through the bleed or the drain connection on the valve body cavity with our DBB saver tool, and we create a vacuum or subatmospheric conditions inside the body cavity, the media flowing from the pressurized side towards the cavity can never leave the cavity towards the safe work area. And we have an animation of this. Vincent will now run for us. All right. So in that animation, you saw before and after, basically. So before, when you open the bleed and there's you observe a flow, you can never be sure the cavity is fully depressurized, and there's always a potential flow towards safe work area. And when you connect the double block and bleed safer, you make absolutely sure there is no flow possible towards safe work area. And especially for toxic gases, this is a very, very strong tool, because you will avoid 100% any chance of any molecule of the toxic media to enter the safe work area. So we have some really strong references on offshore with some major oil and gas companies. On this slide, you see a selection of those jobs we did recently. And gas and liquids are quite obvious, but also LNG and LPG is a very good application field that we're in. And you see on the right-hand side in the middle, instead of connecting the double block and bleed saver directly to the drain in this case, we first run it through a vaporizer, and then we run it through a catcher, a knockout vessel, and to be sure there's no liquids or slugs present anymore. And then we run the vapors through the double block and bleed saver. So this is basically our technology. If there are any questions?
Okay, I will kick off then, Jeroen. Thanks, that very, very nice technology, especially when you design an isolation that gives basically more confidence of having a reliable isolation.
Right.
You mentioned if there is an overflow, basically an alarm will sound. Can you elaborate a little bit on the capacity of this system?
Yeah, we have tools in different sizes. We have currently 3 sizes. The smallest size is our regular tool, we won't call it small, and it has a capacity of over 2 cubic meter per minute of gas, and in that sense also liquid. And our biggest tool so far has got a capacity of 6.8 cubic meters per minute, so 6,800 liters per minute. And we have done with a special application, we've done over 20 cubic meter per minute leakage. So that is a really huge leakage that we have.
Yeah.
So basically the capacity of our tool is not limiting let me put it this way, principle is not limiting the capacity. So we can do anything upon customer's request, and also pipeline diameter and pressure class are not limiting us.
Okay, thanks. I see there is a question basically from Wim. What is the risk of mixing of the gas from the leak with oxygen from the safe area?
Yeah, that is possible, of course. So in the cavity or in the bleed section, you can get a mixture when there's a leakage of from the safe work area towards the bleed section. We have foreseen this. This was also a Shell approval point for the worldwide approval to get this covered, and we did. So what we do is we have the design of the tool is such that we drive it with nitrogen, and the compressor. So the drive of the compressor is actually a Venturi pump, and we drive it with nitrogen, and it means that we mix the nitrogen with the mixture of gas and oxygen or air coming from the safe work area in such a ratio that it is mechanically prohibited or impossible that we create a flammable mixture in the exhaust of the tool, where of course ignition sources can be in the exhaust. And also we have a LEL measurement in the inlet of the tool, so we know what we are doing, and we know where the leakage comes from.
Okay, thanks. Thanks for that.
Yeah.
And another question, basically. So you mentioned gas and you mentioned liquid. What happens if fluid enters unexpectedly instead of gas? Is that a problem or not?
And the tool can handle liquids, but the environment can't handle liquids that comes out of the tool of the vent pipe, of course. So you want to avoid it. So for dry gas, we just connect the double block and bleed safer as is. And for wet gas or for liquids, where we extract the vapors, we will use the knockout vessel to knock out any liquid, and we can empty the knockout vessel online during the operation. So yeah, we will make sure we catch the liquids, so they won't pollute the environment.
Okay, thanks. Another question came in: if the movie is available, basically when working in the field, just to show to the customer. Can you see it on top?
Yeah. Or if it's available. What's the question? Is the show movie available for deployment? Sure, no problem.
Yeah, it's a nice animation. I found it also really nice. Wim as well, I see. So very good. Are there any other questions from the people on the webinar? So maybe then the last question from my side, the same as with the FitMachine, basically. What is required on resources to implement? Of course, I understand resources required from Valvetight, but what does it require from me being a company to implement this?
Well, we have different models. One model is the rental model that the customer just calls us, and we will solve the problem. And then after the maintenance work is finished, we pack up, rig down, and we will leave until next time. And we use our own resources for that. Another model is for customers who have leakages occurring often and want to use this tool on a more permanent and long-term basis. We have an operational lease model, so the customer becomes the availability of one or more of those tools, and we will train their people to operate it, and then they can do it themselves basically, and they still can call us for assistance for special cases. But we offer the opportunity for the customer to operate the tool themselves if they lease it long term, basically. Yeah.
Okay, thanks for that, Jeroen. I think looking at the time, back to Vincent.
Yeah, so indeed, thank you very much for the presenters today. I think, again, two very interesting technologies from the technology catalog. So thank you very much for that. And for all of those online, thanks again for joining. And if you have any further questions, don't hesitate to get in touch with the presenters or just send us a note to info@deploymentmatters.com and we'll make the connect for you. And we hope to see you online again for the next webinar in a couple of weeks' time that will be announced via our usual LinkedIn channel. So thank you very much and goodbye.
Thanks, everyone.
Cool.